Hey everyone, today we're going to talk about segments and how to measure them. And I'm going to go through two methods with you. One's called the ruler postulate, and you can see a picture of a ruler there. It's basically a way to just count and find the length of a segment. And the second way is called the segment addition postulate, which we'll go into a little bit more detail later on. So just a quick review, a segment, remember, is a part of a line that consists of two endpoints. So there's a start and a stop. And so from there, we can use a ruler to actually find the distance between 2 points. So if you look at this first example here, we want to find AB. The easiest way to do this, honestly, is just to take your pen or pencil, excuse me, start at A and just count. 1, 2, 3.5. So from A to B is 3.5. You can see that here. Now you may notice the absolute value bar is in a subtraction sign and be wondering, where that comes into play. That's actually called the ruler postulate. And basically the ruler postulate is listed right above here, but basically you just take the absolute value of the difference of the two endpoints. And if you put that in layman's terms, that just means you take the two endpoints and their values, you subtract them and take the absolute value. Right? Absolute value is always positive because it's a distance and there's no such thing as a negative distance, and so your answer will always be positive. Okay? Let's take a look at a couple of examples and show you how this ruler postulate is put into play. So the first question right here says find the length of AB. Now the easiest way to do this, again, is just to take your pen or pencil, start at A, check the number line to make sure you're aware of the units and where they're increasing by. So in this case they're increasing by 1. So I can just start at A and go 1, 2, 3. I know very simply that just counting, I'm going to get AB is a 3 units long. Okay. Now if I use the ruler postulate and this difference of the endpoints and take the absolute value, you actually just draw your absolute value bars, figure out what point A is, in this case -9, subtract that from the -6. Okay, and it doesn't matter the order of which you put the -9 and the 6 because its absolute value is all going to turn out positive. Double negatives become positive here, and so you have -9 and a +6, which becomes the absolute value of -3, and the absolute value of -3 is 3. Okay. There's one right to the right of it here which asks you to find the length of BD. Go ahead and hit pause and you can try that one on your own, and I'll check back with you when you resume play. Alright, so we're back at it here. We're finding BD. Again, the easiest way to do it is just to count. Start at B. 1, 2, 3, 4, 5, 6, 7. So you can just count with your finger and get 7. If you go the other route and use the ruler postulate, I'm going to kind of go backwards. Over here I started with A and then went to B. I'm going to actually start and use D's point, which is +1, and I'm going to subtract from that B's point, which is -6. Again, simplify what's inside the absolute value bars. Double negatives become positive, so you get the absolute value of 7, which is in fact 7. Okay. Now you may be wondering, this seems pretty easy, and a lot of students would be asking themselves, why can't I just count every single time? And the reason we use the ruler postulate is when you have a number line that has a lot larger values. For example, okay, if I had a number line here, move this up a touch here for you so you can see it, and let's say I had a -30, here's 0, and this was 25, okay, and I'll call this A and I'll call this B. You really don't want to count all the way from 25 back to -30 or vice versa. That's a lot of counting in between those spaces. So if you just take the ruler postulate and take your 2 points, -30, subtract 25, that's going to give you a -55, and the absolute value of -55 is +55. So the distance from A to B on this made up example would be 55 units. So when you get larger numbers, using the ruler postulate is going to make your life a lot easier. Okay? So that's standard number 1, or learning target number 1. The second learning target deals with the segment addition postulate. I'm going to give you a quick example. I did this earlier, but I have this piece of paper and I wrote segment on it, and basically what the segment addition postulate says is this. If you take and separate your segment and then add them together, the two separate pieces will make the whole segment. I know that seems like common sense, and the good news for you is it is. Okay? The segment addition postulate basically states that if you take one piece and add it to another piece, it gives you the entire segment. Let's put it into practice here on the back side, and I'll kind of show you how really easy this can be. Alright, so this first example here says use the line segment addition or segment addition postulate to answer the question below. Alright, get this straightened out here for you. It tells you that EM is 8, okay, and you can write 8 in there for the length of EM, and MG is 10, so you can put 10 in there for MG. It says what is EG, which is this entire length right there. Well, if you know that EM is 8 and MG is 10, 8 and 10 make 18, and you get EG being 18. Okay. Some students may want to write this out, and what I mean by write it out is this. They know that EM plus MG equals EG, and then they just use substitution. They substitute in the 8 and the 10 for the values, plug them in, and go. Okay, right below it says EG is 22, so this is a different type of problem. It says EG is 22, so you know the entire length is 22, and MG is 7, so just a smaller part of it is 7. They want to know what EM is. Well, again, if you use segments to write out an equation where EM plus MG equals EG, you can substitute these values in, EG being 22, which is now over here, MG is 7, and you want to find what EM is, so you can just leave that as EM. You could call it X, okay, and then you would just solve this for X. You would just subtract 7 from both sides, and you would see that X is equal to 15. In other words, EM is equal to 15. Okay. Again, there's a problem right next to it. Go ahead and hit pause and give that a try, and then I'll check back with you here in a second. Okay. All right, so we're back, and it's a very similar problem to the one we just did, so I'm going to go ahead and get started on this. If VP is 8, I'll use the picture here and draw in my 8, and PG is 2. They want to know the length of this entire segment VG, which is going to be 10. 8, 2 makes 10. Okay. The one right below it, VG is 8, so now they're saying this entire thing is 8. All the way from V to G is 8, and PG is 2. What must VP be? Okay, so I'm going to kind of scribble this out since I'm using pen. But if this entire distance right here is 8, and part of that 8 is 2, that means this has to be 6, because 6 plus 2 has to give the entire length of 8. So I kind of showed you some different versions of how to write it. Some of you can do this in your head, and these are very basic segment addition postulates. They're really just used to kind of drive home the point of what the segment addition postulate is. All right, right below these are a couple two challenging problems that really make you use some algebra and apply the segment addition postulate using some of your skills that you learned last year in Algebra 1. So, very similar looking question, and asks you to do something very similar to the problems above. So now you'll notice that on the segments, we don't have nice neat numbers like 7 or 10 or 8 or 2. We actually have algebraic expressions. Alright, so in this case we have EM being 4x minus 10, and we have MG being 2x plus 8. Now, the directions are real important here. In the directions it says EM is equal to MG. This is very important information. It's going to allow you to set up the problem. So if I know this distance from E to M is the exact same as M to G, then I know these two expressions have to be equal to each other, because EM equals MG. So that's exactly what we're going to do. I'm just going to write 4x minus 10 is equal to 2x plus 8, and I'm going to solve this for x. Okay, I'm going to minus my 2x from both sides. I'm going to get 2x minus 10 is equal to 8. I'm going to add 10 to both sides. I'll get 2x equals 18, and then I'm going to divide both sides by 2 and get x equals 9. Now let's not get in a hurry and think that we're done just because we found x. Let's take a look at the left-hand side here. We actually have to find 4 different answers to this problem. The first one is x, so that's nice. We just found that to be 9. We can fill that in. Now number 2 says we got to find EM. Well, if we know EM is really 4x minus 10, we can take our x value of 9 and actually plug it in for x and use substitution. So 4 times 9 is 36, and 36 minus 10 is 26. Number 3 says mg. Now, you can do this one of 2 ways. Some students are going to go ahead and plug 9 back in for this x and get 2 times 9, which is 18, and 18 plus 8 is 26. Or, if you understand the concept and you understand the problem and the directions, which says that EM is equal to mg, if EM is 26, then mg has to be 26 because of what the directions told us right here. So that's 26. Last one, number 4, EG, which is the entire segment length. So they want to know that whole distance from E all the way to G. If both of these segments are 26, we just add 26 plus 26, which gives us 52. There's a problem right to the right of this problem. And go ahead and try that. Hit pause and go ahead and try that. And then check back with me here in a minute when you're done and see if you did it correct. Alright, so we're back here. These problems look very similar to each other. However, the directions listed for problem number 2 here are different. We do not know that these 2 segments are equal to each other. It doesn't say that in the directions. In fact, it says this. They're saying if VG is 21, then find these 3 things. Now, VG is this entire distance right here. So we know that entire distance is 21. So we're actually going to use what we used in the 2 previous example problems before we did this one right here. I know that VP, which is from V to P, plus P to G, has to equal the entire length of VG. I know all of that. So what I'm going to use is substitution. I'm going to go 2x plus 6, which is VP. I'm going to add it to x plus 9, and that has to equal 21. That's the segment addition postulate. Take 2 parts of the segments, add them together, you get the whole thing. So now you need to solve this for x. Now you have x's on the same side of the equal sign. I always used to put a dotted line here. That's like the wall, right? So these are on the same side of the wall, so you just add like terms. There's really a 1 there, so you have 3x. 6 and 9 added together make 15, and you have 21 there. Subtract 15 from both sides. You get 3x equals 6. Divide both sides by 3, and you should get 6 divided by 3 being 2. Again, don't get super excited and think that you're done before reading the rest of the problem. We have x equaling 2. That's one of the things we need to find. We also need to find VP and PG. So we're going to use substitution again. We know that VP is 2x plus 6. Now that we know what x is, we can take this 2 and plug it in. 2 times 2 is 4. 4 plus 6 is 10, so I know VP has to be 10. Now there's 2 ways to find PG, which is this smaller segment here. You just found VP to be 10. You know the entire length is 21. So what must this have to be? What must this be for PG? Well, you can just do simple arithmetic. You can just go 21 minus 10 and get 11. If you didn't like doing it that way, you could also take your x value of 2 and plug it in for PG right here. 2 plus 9 is 11. So there's 2 ways that we use the segment addition postulate. Just be very careful of the problem, because if you notice the visuals look pretty similar to both problems, but the directions or the information provided to you is different. So be very careful when doing these problems on your homework that you look at the visual, but also look at what the information is providing you with. That will point you in the right direction in terms of how to set up the problem, whether you're setting them equal to each other if it tells you the 2 segments are equal, or whether you have to use the segment addition postulate and take each piece, like these 2, VP and PG, and add them together and set it equal to the entire length. Okay? Wish you the best of luck on your homework. If you have any questions, any loose ends to tie up when you come to class tomorrow, I'll be happy to answer those questions and help you get that assignment done. All right? We'll see you back tomorrow.